All right, so let's talk about project management. Okay. This comes from your managing by business process flows. There's an appendix 4.2, all right, and then it comes from chapter 5 from your operations textbook, and there's a PDF of that chapter out on in that module, all right. And so project management has just, sorry, we should be able to, there. It encompasses a ton of different things, right? Anybody in here been involved in a specific work project? Hunter, can you describe one of them?
We had, like, this summer, the internship that I was doing, we had a install all the tooling and conveyors in the final area at the Ford truck plant for the new aluminum body trucks.
So, and then I think you shared a little bit about that. About how many people were working on that project?
There were over 500 iron workers and millwrights and laborers on our end, and then we were working with 300 electricians and over 300 pipe fitters as well. So it was pretty immense construction process.
And how long did you have to get it done?
Week and a half.
A week and a half. So 800 workers to get stuff done in a week and a half. It reminds me of one of those TV shows where they go in and do a quick fix, right? Or they go in and. So how did you organize? How did they organize those employees? How did they keep
About the first 2 months of the summer, even before I got there, before I got out of school, they were already planning everything, and I kind of came in mid-stride, and they just organized everything. All the drug testing for every single employee had to be drug tested, had to have new hire forms, everything, all their safety training, orientations through the Ford Motor Company had to be handled. They had to, and it was just, I mean, it's a logistical nightmare, but the way that we attacked it was pretty outstanding in my views to do what we did in such a short time. And I mean, we had people from all over coming. We had people as far as Las Vegas, as close as right there, and out of the union locals right there in Louisville where we were working, and it was pretty immense.
Did they use any particular software to help manage it? No?
No software.
Okay.
Just all old school pencil and paper type stuff, because you can capture some of the stuff that, you know, if you were using an actual program, it'd be kind of hard to make certain little various inputs and stuff that they. I mean, we used Excel sheets a lot, and, you know, made small databases, you know, organizing, you know, by crew.
Project, yeah. And then I would assume you kind of looked at it and said, okay, well, we need them to be on site here, and at that point they need to have been drug tested, they need to have been safety trained, so you kind of have to, here's a critical point, and then you kind of back up from that with the other things that need to be done.
Yeah, we put in place, the first thing we did was all the foremen that were on the job, which they kind of have like a 5-man crew underneath them. We paid for them to come in a week ahead of time before the job started to start getting tools ready and get, you know, everything organized and kind of schedule when their guys would show up. And we kind of like based them, like the guys that they were working with were guys that they worked with on other projects, so they would work well together, and they just weren't meeting each other for the first time. So we just had that structured that way, and they would come in, and, you know, first step would be to go through the drug test before we paid for them to go through the Ford orientation and safety orientation, and then they'd get all their PPE and make sure they had their tools in. And then the day that Ford shut the plant down, we had all our operators haul in, you know, personal tools and everything, and it just was a huge swarm.
Gotcha.
So
again, so projects can be very complex to something that's much simpler. Probably what we're going to start with are things that are much simpler, right? So the things that we're going to look at today are going to be maybe 6 or 8 steps. I mean, I can't imagine the hundreds of steps that are involved in the coordination that you just talked about, right? But the project management, it scales accordingly. So I think you'll learn some things here that you can scale up to projects of that size, okay? So one of the questions we have is what is a project? Okay, it's a series of related jobs, right? Usually directed towards some major output and requiring a significant period of time to perform. Okay, project management is the planning, the directing, and the controlling of those resources. So, Hunter, you just talked about all of that in your description of your project. And project management is important because at the highest levels of an organization, management often involves juggling portfolios of many projects, and you have to select which ones you're going to do, and then determine kind of which ones are the most important. Okay, I will tell you when I worked at Pella Corporation, and we're going to talk about some different types of project structures today. The guys that were in project management were usually the ones that were fast-tracked into upper management, because if they do that well, right, then that's the same kind of skill set that folks need in order to run their own plants, their own divisions. So again, it was a good kind of testing ground for people that weren't quite ready to have their own plant, their own division, but were showing promise. And so you would see those very talented individuals go in through the project management approach. Okay, so here's just a little, humor. Project management gone wrong. So here is a swing, how the customer explained it, right? How the business consultant directed it with a big sofa in there, right? How the analyst designed it. So let's cut the tree down and then put the swing underneath it. How the programmer wrote it, right? So it's off to the side. How the customer was billed, that's my favorite, right? So the customer got billed like a big roller coaster, and all they wanted was the tire swing to begin with, okay? And that one's been around for ages. Okay, so we're going to talk today about some different types of projects, and what you're going to see is we have kind of different degrees of projects, right? And what you're going to find is kind of off to this side, off onto the right-hand side underneath the derivative projects, they're not as complex, right? And as you move to the breakthrough projects, you're going to find that they're more complicated, okay? And so if you talk about, let's just do the product change type of projects here, okay? And so a derivative project is just like a product enhancement. So talk to me about iPhones. Like what's the not the most recent, but the model before the most recent. What's the iPhone model that you're on? 6. Okay. So on iPhone 6, have they come out with any new product enhancements? No? Not that you're aware of?
The S, 6S.
Okay, so 6S. And so what do they do in 6S that's different from 6?
They have like that 3D touch. They have, I think, maybe a better camera, something like that.
Okay, so basically all they're doing is they're enhancing their current product, right?
Correct.
So that's less complex. That's usually making some adjustments on a production line, right? And then you move to platform projects, which is additional. It's in addition to a product family, okay? So if I'll use Pella Windows as an example there, okay? For product enhancement, right, we might offer additional colors, right? External colors, that would be a product enhancement. For in addition to a product family, what we might do is we might have a product family that doesn't have, maybe it has double hung windows and doors, but it doesn't have casement windows. So now we're going to add casement windows to that particular product family, okay? That would be in addition to the product family. And that typically requires some additional processes as well as a product change, okay? And then you talk about a new core product, okay? A new core product is going to be a breakthrough product that typically you haven't done before. One of the things I can tell you about project management that I learned is that if you're implementing a project in your facility that you've already done in your facility, you probably need to give yourself about a 10% buffer on your costs, okay? Because you've done it before and you know what you're doing, okay? If you have done it in another plant, but you haven't done it in your own facility, right, you need to give yourself a much larger buffer, right? Because there's going to be things that the other plant experience that they're going to forget to tell you about. Okay, so there's going to be this gap in knowledge, and you're going to try to estimate what that project is going to cost, but there's going to be this gap in knowledge. Then you get here in these breakthrough projects, and man, they can run 10 times to 100 times more than what you think, because you don't know what you don't know. Okay, this is the kind of thing. We had a paint line project in Carroll, Iowa, and the paint line project was it was technology that had never been used before. Okay, so the problem with that is you think you know, you line out what you're going to do, and then you start to experiment with it, and it doesn't work like you think it's going to. So then you've got to go back to the drawing board, right? So anytime you get into new technology, these breakthrough projects, you just have to be aware that those costs they can escalate on you, okay? Process changes kind of go along that same way. A derivative project is just going to be an incremental change. We're just adding something. And let me just make sure that you're all clear on the difference between product changes and process changes. Okay? So product changes is you're looking at the end product and you're saying this is what's different about it. Okay? Process changes is you're saying as I look, if this is my manufacturing line, I'm looking down the manufacturing line and these are the things, the steps that we have to do differently in order to produce this product. Okay? And so you've got, and you often have product engineers and process engineers, and they're wired very differently. Product engineers are often about research and design and new innovations into the product. Process engineers are about this production line and understanding the equipment that's available and what is it that we can do to make this at a lower cost and more efficient. You know, so I would talk about these folks are trying to hit the effectiveness. They're trying to make sure that the product meets what the market needs. These folks are about efficiency. They're trying to make sure that as you produce it, you're producing it at the least amount of cost. Okay? So in a research and development, right, again, an incremental change versus a technology upgrade versus new core technology. Alliance and partnership, incremental change, you're selecting a new partner, maybe you're going to outsource, right? And so you have these degrees of projects that get, you know, can get progressively more complicated. All right? So probably enough time on the types of development projects. But we're looking at degree of change and then type of project. So we're going to talk about these three different types of project structures. We're going to talk about a pure project, okay, which is a self-contained team that works on the project full-time. We're going to talk about a functional project, which is the responsibility lies within one functional area, okay, and then a matrix project is a blend of those two, all right? And we've got a slide on each, so I'm not going to spend a lot of time there, but I think I went too far. The pure project structure. You have a project manager, and they have a number of resources available at their disposal, okay? When Pella decided to go to a new enterprise resource planning system, right, that's a millions of dollar decision for them, right? And they felt it was worthwhile to have a project manager and put together a team of people that was their sole responsibility was to go out and identify ERP software that was available, evaluate the software, bring it down to 2 or 3 choices, take that out and present it to everybody in the organization, get feedback from those people, and then make a recommendation to upper management, okay? Those people were assigned to that project for a minimum of 2 years, okay? And then what they did is they said, okay, well, you've been on here for 2 years, right? I think I can't remember if there were 10 or 13 people on the team. And so in year 3, then 3 of the people go off the team and they bring 3 more people on, right? So then they kind of rotate people on and off the team so that they got a good array of people that were trained in that software and could go out and work in the organization. There are some advantages to that type of a project, right? The project manager here has full authority, right? If you work for me, I can say, Zach, you need to do this today. And Zach's going to go, okay, I work for you, no problem, right? At the end of the year, I'm doing Zach's evaluation, right? So he's really motivated to make sure he's performing well because he knows that that's going to make a difference to him in the long run, okay? The team members only report to one boss, okay? You have these shortened communication lines, and you can get some team pride and motivation coming through, okay? The disadvantages are, right, you can have some duplication of resources, okay? I'm probably, let's say, depending on the type of project, like in the ERP one, I'm going to have some IT resources that are going to be here, okay? But I've also got a whole IT team. So I've got people who know how to do the same types of things, and I've got them isolated over here versus working within the organization. Okay, so you have these duplication of resources, all right? And there can be this lack of technology transfer. Now, I talked to you about how Pella tried to deal with that by rotating people on and off the team. But if this team is isolated, then it's hard for them to get that information out to the workforce, right, to the people who actually need it. Okay? And when it's over with, these people have no functional home, right? So let's say the project ends, now you've got these 13 people, and you have to make sure that, you know, where are they going to go? Right? And so if you're going to be on that team, you have to be comfortable knowing that at the end of the day, at the end of the project, you're just going to have to look at what positions are available and hope for the best, right? So that's not always a real comforting thought when you're in that position, okay? Oftentimes, though, if you perform well, right, then there's some good opportunities at the end of that. Additionally, we have the functional project structure, okay? And so each functional area has a series of projects that they're working on. So in manufacturing plants, oftentimes they're tasked with a certain cost efficiency improvement year over year. And they're going to have a list of projects that they're going to work on within their facility, okay? And so they're owned and managed by this group of people. The engineering team will have the same, the research and development team will have the same, okay? So in functional arrangements, power or status is defined by that vertical hierarchy, okay? Functional structures common in large organizations like central governments, right? Local governments, police forces, armed forces, most large private companies, right? They have these functional areas, okay? Some of the things that we talk about in terms of advantages, okay? A team member can work on several projects at once. They're not just isolated to one project. Technical expertise is maintained in the functional area. The functional area is still their home once it's all done. And you have this critical mass of specialized knowledge. Okay, disadvantages. Let's say I'm working on a project in manufacturing, right, and it impacts some customer service things, right? If it's a functional project in manufacturing, they're not getting the input from the customer service side, and they're likely to shortchange that part of the project, okay? And so, you know, there's some things that you have to be aware of in those types of situations, okay? The motivation of the team members is often not as strong, and the needs of the client are secondary and sometimes are responded to more slowly in this type of a project structure, okay? So then we have the third type that we're going to talk about, which is a matrix project structure, okay? So you have these project managers. These are the folks that I was talking about at Pella that were usually kind of, if they did well, they're fast-tracked to that next executive level, okay? And then you have these functional areas. So for example, I worked in manufacturing and supply chain, so I'm in this, you know, functional area, manufacturing, right? But I would work with the project manager for the Proline division, okay? And he would be responsible for identifying with all of the Proline executives the type of projects that we were going to work on, and he would be responsible for pulling that together. The key to this person is, right, while it shows that I have kind of this dotted line report to him, right, my plant manager is the one that's doing my evaluation at the end of the year, right? So the majority of what I need to do focuses on what does my plant manager, what does he think is important, okay? This project manager has to be a leader that can convince people to do things because of the importance of doing them and getting them done, okay? He's typically someone that doesn't wait. So let's say, for example, you're working on a project and you have a deadline coming up, okay? And, I'm sorry, tell me your first name again.
Kaylin.
Kaylin. So let's say you and Hunter are working together, right? You know you've got this project and there's a deadline in 3 weeks, right? And so this guy does not wait until 2 weeks and 6 days to go, Hunter, where are you at with that, right? He says, week 1, so kind of what's our game plan? What is it that we're going to do? Week 2, you know, Hunter, I just wanted to follow up and kind of see how's that going, right? Week 3, do you want me to take a look at that? I'd be happy to look at that, right? He's trying to be supportive, but reminding you that, okay, we've got these deadlines. We have these things that need to be done. Because in this manufacturing world, these folks have so much on their plate, right? Sometimes they're not going to think about looking at it again until 2 weeks and 6 days, right? And so then all that time is gone, and all they're going to do at the next meeting is, yeah, I didn't have time to get that done, right? And that doesn't promote that project, right? So again, from this standpoint, the advantages are you get better communication between the functional areas because you have representation from each functional area on the team, okay? The project manager is held responsible for the success. The duplication of resources is minimized. You still have that functional home for the team members. Policies of the parent organization are followed, okay? Disadvantages, sometimes you can have too many bosses, okay? Depends on the project manager's negotiating skills, and you have this potential for sub-optimization, okay? But the tricky part is, like, many organizations have so much stuff going on. I found myself, probably one of the last years I was at Pella, I ended up not going to a meeting that my plant manager had called, right? And he called me into his office afterwards and he was annoyed because I had not come to this meeting, right? But I was involved in so many projects, right, that there were things that I needed to get done for the projects, and if I kept going to meetings, I wasn't going to get them done. So we sat down and he said, well, talk to me about this. Why weren't you at this meeting? And I said, well, you have me assigned to these projects, and we've said it's important that we get these things done. And I said, I've got to take the time to get them done. And he said, well, I don't know that you can, skip meetings. And I'm like, okay. So on that particular week, I had 65 hours of meetings scheduled, right? I had meetings on top of meetings, okay? And so that's a challenge that you can run into with this type, okay? Then you find yourself, as in my situation, you just have to deselect, okay? So sometimes you can get too many things on the agenda in that type of a structure as well, okay? All right. Yes, Scotty.
Where can we find where the advantages and disadvantages are? Are they in the book?
Yes.
What chapter is this?
So that's going to be, I think it comes out of the alternate text book. And if you look at the PowerPoint slide, I think the notes are actually on the PowerPoint slides.
Okay.
So you should be able to go to those PowerPoints and bring those up.
Okay.
Okay? If they're not, let me know, but I'm just pretty sure that I put them out there.
I don't think the notes for the beginning of it was, but then it just skips the critical path method. So it's network and planning models, and then it goes to critical path method.
Okay, so let me just take a quick peek.
Oh, maybe I'm on the wrong one.
So you're going to want to be on
I was on the wrong one.
Okay, there you go. Yeah, because we'll go back to that on the next lecture. All right. So when we work on projects, one of the things that we need to do is we have to define the actual project that we're working on. And it's important to understand what the objectives are. So you want to have a written description of the objectives to be achieved. Okay. A lot of times a project can say, we want to improve the efficiency by X%, right? That's a specific objective. Okay. When you're working with information technology, my experience has been that engineers and information technology folks are the hardest resources to get a hold of. Okay. And so if you're working with them, they want you to specifically define what you want out of it. Because if it's in particular with information technology, you can say, okay, well, we need a report, or we need some work documents that the output has this information in it, right? And then they work on it, and you see it, and you go, oh yeah, but it would be so cool if you could add this, right? And then they add that, and you go, right, oh, that's awesome. But even if you could add this, right, and that's what we call scope creep, right? Every time you think you're finished, right, somebody says, no, but wait, we want to do this. Oh, but wait, we want to add this, okay? In projects, you have to, at some point, draw the line and say, we've met the objectives of what the original project was. If you want those things added, that needs to become a new project, okay? And so those are some tough conversations that sometimes need to take place, okay? We try to break things down into tasks, okay, which are further subdivisions of the overall project, usually shorter than several months and performed by a single group or organization, okay? And then you try to, again, keep breaking it down into a work package, which is a group of activities combined to be assignable to that single organizational unit. So you can see we start with the overall project, then we start with tasks that are going to be assigned to groups, and then we identify what pieces of work need to be done within that group, okay? And then you move from that and you go into what you call project milestones. And you say, okay, well, there are specific points in the life of the project that maybe we need to stop and reevaluate, make sure we're still on task with, okay? And then we talk about work breakdown structure, which just breaks those tasks even further down. It gets down to the very specific pieces of it, right? And then down to activities, which are the pieces of work that consume time. All right. So here's a work breakdown structure example, right? So we've got our level 1, and then we have a couple of different projects, right? Within that project, we have some tasks that are going to be assigned to a specific group, right? Within that So within this task, right, then we've got 2 groups here, and then we have a work package associated with each group, all right? What I want you to recognize is that we're spending 3 class periods on project management. You could actually spend an entire semester on a project management using some project management software and understanding the skills. So we're just doing kind of a high-level overview of project management, kind of what the specific components of it are. Okay? And so here's just an example of this work breakdown structure for the project is a large optical scanner. Okay? So the level 1 is this optimal simulator design. Okay? And then when we start to say, well, what kinds of things need to be assigned to different groups? We've got the optical design, right? We've got the overall system performance analysis, right? So you can see those would be different groups, okay? System integration, cost analysis, management, and long lead item procurement, right? So those are different groups that are going to be responsible for that. And then again, we just go within that group. So for long lead item procurement, okay, well, we need to do large optics, target components, and detectors, right? So now you're just breaking it down into that next level, right? So each piece is just, okay, let's keep drilling down, all right? So when we talk about project planning, okay, the project is made up of these sequence of activities from a network representing a project. And so what we're going to work on today is just doing some network diagrams and then starting to talk about start times and finish times. Okay, so the path taking the longest time through this network is what's called the critical path. Okay, so Hunter, do you remember what was going to take the longest time on your project from this summer? Was there a particular piece that took longer than the others?
Planning.
The planning part of it. Okay, but when you were actually on site, when they were working on the project, was there a component that was maybe more critical than others because the rest of it couldn't happen without that piece of it?
Oh yeah, I mean, well, there was like so many that were like that though, like it all just had to fall together so much. You had to make sure that all the tooling and machinery and conveyors and everything came in right, and they were the right size and measured and double checked and checked before they went in, because we only had a short window of installation. So every step leading up to when they said, hey, you can go in the plant and actually do your work. Right. There was so much more work to be done outside of the week period.
Because then it was just going
because it was just purely installation once that went in, and
okay.
Then that was like the biggest.
So as we think about the project, I think what we'll see is we could probably identify out of that the things that took the longest would become the critical path. So let's say that you had some equipment that you had to order and it had a long lead time, right? If you miss the time that you need to order that, right, you've now delayed the entire project, right? And so that's when we talk about the critical path, that's the kind of thing that we're talking about. If I miss the timeline that I have on this, then it delays the entire project. And in complex projects, there's a lot of pieces that can go into that. Probably in what we're going to look at in what we're looking at today, it's going to be much more simple than that. We're just going to find a couple, maybe a path or two through the project. So the critical path provides a wide range of scheduling information that's useful in managing your project. Okay, it helps to identify the critical path method identifies that critical path in our project network. Okay, so in order to do the critical path method, these are the steps that you need to take. You need to identify each activity to be done and estimate how long it will take. You determine the sequence, and then you construct this diagram that says here's the sequence of things. Then we look at earliest start time and finish time and latest start time and finish time, and we determine the slack time for each of those. And these will make sense as we kind of walk through some examples. Okay. And I would say that the set of steps here is slightly different from what's found in that alternate textbook, because it doesn't address calculating the slack time, and that's something that I want you to know how to do. So this is kind of a combination of the managing business process flows and that chapter 5 alternate text. Okay, but here's our first kind of example. We're going to identify these activities, right? And so our activities are, we're going to design, build the prototype, evaluate the equipment, test the prototype, write the equipment report, write the methods report, and then write the final report. All right? And so it's often easiest to assign letters to these tasks, because when you draw your diagram, it's a ton easier to reference the letter than it is to try to type in all of that on your diagram, okay? So these are our tasks, right? And then it says, what's our immediate predecessors? Well, what that means is I can't build my prototype until I have the design, right? So A has got to be done before I can do B, okay? I can't evaluate the equipment until I have my design, okay? I can't test my prototype until I've built my prototype, right? And so you're just trying to identify what has to be done beforehand. So, you know, I could use the example of if you're making a pizza, right? What's the first thing you do when you're making your own pizza?
Yeah.
The crust.
You have to put the crust down, right? You have to make the crust, put the crust down. What's the next thing you have to do? Not have to, but what would you do?
I work at Domino's.
Okay, so tell us how you, so we have a pro here. Tell us how you put a pizza
So you
together.
have your cornmeal and you have your dough patty, and you have to spread out your patty.
Okay.
And then toss it, whatever. You put it on a screen and you sauce it and cheese it.
Okay.
And then from there you put on your topping.
Okay, all right. And so in that example, right, it wouldn't make any sense to try to do the toppings before you did the crust, right? There's a specific sequence of things that have to occur. And that's the case for most projects. So that's all we're trying to do in this arrangement is identify what's got to be done first before that can be done, okay? And then we try to assign time to those tasks, right? Well, how long does it take us to do those things? And in this case, we're talking about weeks. It's 21 weeks for design. It's 5 weeks for building the prototype. 7 weeks for evaluating the equipment, 2 weeks for testing the prototype, 5 weeks for writing the equipment report, 8 weeks for writing the methods report, and 2 weeks for writing the final report. Okay? And so, you know, in an oversimplified version, somebody might say, well, let's just add those up, right? But the reality of it is, these things can be done, some of them can be done at the same time. And so that's, like I could be working on building the prototype at the same time that I'm evaluating the equipment. Right? So it makes sense then that we would draw this precedence diagram. Let's see how this. So this is the precedence diagram that comes from that slide. Okay? And I'm just going to take a minute here. I think I'm going to take a minute. Maybe. So you have to bear with me this first time through. I haven't used the Elmo in here in quite some time. And I may not be able to get there today, but I'm going to give it a shot here. Okay. Well, that's not working for us. Okay, sorry. So for today, I'm not going to be able to do that. So I'll come up with Plan B. And so for Plan B, I'm just going to draw on the bottom here. And I'll kind of show you how they come up with that diagram. Okay, so if I'm drawing a precedence diagram, and I want to draw it on here because I want you to be able to see this chart while we're drawing it. Okay? So the first thing I'm going to do is I'm going to look for what activities do I have that don't have any predecessors. Okay? Because that's going to tell me that's the beginning of my project. Okay? If this is your actual project, you're going to know that, right? But in this case, we're trying to read what somebody else has written for us, and so we're saying, okay, well, task A has no immediate predecessors. So I'm going to go ahead and put task A here at the beginning, and I'm going to put it in a circle to indicate that that is a task, okay? And then I look and say, well, what follows task A? Well, I can see that both tasks B and C follow A. So I'm going to put B here and C here. And you're just going to pretend I've drawn circles around those, just because with this technology, it's not the easiest thing to get those circles drawn. So now I can see that B follows A and C follows A. So I can go, okay, well, I've done that one, I've done that one, I've done that one. And then it says that D follows B. So I go ahead and say, do you see where I'm getting that? I'm looking at D, and its immediate predecessor is B. Okay. Then I look at E, and its immediate predecessors are C and D. Okay. So then I'm going to go ahead and draw E, and it has to follow both C and D. Okay. And I'm going to follow, and then I need F, right? And F is also going to follow. Makes it a little messy, but it's going to follow both C and D. And then G follows both E and F. So now I've got everything drawn. So there's my diagram, right? That's how, that's your precedence diagram. That's a sequence of things that need to be done. Okay? And I typically go ahead and add in then right up here in the kind of right outside of that, task A takes 21 weeks. Task B takes 5 weeks. Task C takes 7 weeks. Task D takes 2 weeks. Task E takes 5 weeks. Task F takes 8 weeks. And task G takes 2 weeks. Okay? So now I've got my precedence diagram done, and it has all the times associated with it on the diagram. And that allows me then to move on to the next step of the project. All right? So that being said, I'm going to go ahead and go to the prettier diagram, right? So that's what we just drew, right? But you see, I wanted to show you how you look for those predecessors to know how to create the sequence. It's not hard. It's just making sure that you look at those predecessors and go, okay, well, B follows A and C follows A, okay? All right. So if we were to go back to what are our steps, to identify each activity to be done and estimate how long it will determine the required sequence and construct a network diagram. Okay, we've done that. Now we need to do the earliest start time and finish time and the latest start time and finish time. This is the one that takes, it again is not hard, but it just takes a little bit of thought in terms of how you're going to do it. Okay, so we're going to start with, up here I'm just going to show you that I put the earliest start time on this T diagram, and I put the earliest finish time on the top, and on the bottom I'm going to put the latest start time and the latest finish time. And we work through the diagram from left to right, and we do earliest start and earliest finish first, and then we move our way back through the diagram and do latest finish, latest start second. Okay? So, as an example, I'm going to start with task A, and I'm going to draw my diagram. So, what week is the task A going to start on? Starts at 0. How long does it take to do?
21.
So it's going to end on 21. So if it ends on 21, where does C start?
21.
Say it again?
21.
21, right? And how long does C take?
7.
So when is it going to end?
28.
right? So earliest start is 21, earliest finish is 28. Okay? If I come down to B, what's the earliest start of B? Is it Andrew?
Yes.
Yeah, what's the earliest start?
A.
Okay, so it's when A is finished, so what's the time?
21.
21, right? So my earliest start is 21. Tell me your first name.
Emily.
Emily? So then if B's earliest start is 21, what's its earliest finish? How long does it take to do it is probably the intermediate question.
5 days.
5 weeks?
5 weeks, I'm sorry.
That's okay. And so then its earliest finish would be
26 weeks.
26 weeks, right? Okay. Then I go on to D. Scotty, what's the earliest that D can start?
26,
26. And what's the earliest it can finish?
28.
28, right? Okay. Hunter, yours gets just a little more tough, but not too bad. Okay. I've got 2 arrowheads coming into E, right? So that means that I have to backtrack to the 2 tasks before that. One of them finishes at 28. Actually, they both
The other one
finish
finished at 28, so it's 28.
So it's 28. Okay? And so what's the earliest finish?
That would be 33.
33. Okay? Kaylin, is that right? Okay. So again, I've got 2 arrowheads coming in. They both are at 28.
So 28,
28 plus 8,
36.
36. Okay? Courtney, you get the harder one. So I've got 2 arrowheads coming in, and it's not hard, it's just a rule of thumb. If I have 2 arrowheads coming in, and remember what we're saying with the precedence diagram. We're saying that before I can do G, both of these tasks have to be finished. Okay? So if both of these have to be finished, and this one finishes at week 33, and this one finishes at week 36, what's the earliest that I can start G?
Could it be 33?
Okay.
Well, you could get an idea, couldn't you?
Actually, what we're saying with the precedence diagram is I can't start G until both of those tasks are finished.
36.
So it's got to be 36. Okay. So that's the only time we start to any trickiness in this earliest start, earliest finish is just when you get to when you have 2 arrowheads coming in. For earliest start, you have to say both of those have to be done. So if that's the case, then that's 36. And how many weeks does it take to do that?
38.
So 2 weeks. So then it becomes 38. So now I have my earliest start, earliest finish all the way through the project, okay? Then I come back and I do my latest finish, latest start, okay? So I take that last earliest finish and it becomes my latest finish. And I subtract 2 and it becomes 36. So the latest finish that I can possibly do on that task is 38. The latest start time is 36, okay? If that's the case, then this latest start time becomes the latest finish time that I can allow this task to do and this task to do. Because you see I've got those 2 arrows coming back from that. Okay, so Zach, if this is 36, for activity F, if the latest finish is 36, what's the latest start?
How'd you get 36 for the latest start time for F?
For the latest finish
Oh,
time?
excuse me, finish time.
Yep, so it's the latest finish time because so on earliest start, earliest finish, we do what we call the forwards pass. So we go this direction, right? And so we're adding things. On latest finish, latest start, we're going this direction. So I'm saying I start at 38, I subtract 2 weeks, that means that my latest start time is 36. If that's my latest start time, that means the 2 tasks before that have to finish by week 36, right?
Okay.
So I get my latest finish at week 36, and this takes 8 weeks, so my latest start time is then what?
28.
28, right? Okay. Andrew, for
Yes.
task E, I've got my latest finish for task E is 36, so my latest start is what?
Is that one going to be 28 as well?
It is not because this one only takes 5 weeks. So it's going to be 36 minus
Yeah,
5.
31.
31. Yep. So this is where we start to see anything that has no difference between earliest start and earliest finish and latest start and latest finish is on your critical path. You have got to do it, right? If there is a difference here, this is saying that I basically have 3 weeks of slack time, right? My earliest start I could start would be 28 weeks, but my latest start is 31 weeks. So there's my slack time for that activity. It's 3 weeks, right, that I have to play with that. If it goes into 4 weeks, now it moves on to the critical path because now I'm going to impact the time that that project can be finished, okay? So, Emily, let's do C. So in C, I can't find, there's my arrow. F comes back from that, right? And E comes back from that, okay? And so basically, I have to make this decision. I have to think this through. So what we're saying is that the latest start time for F is 28, and the latest start time is E for 31. And C has got to be done before I can start either one of these. So am I going to use the 28 or the 31? What do you think?
31.
Nope.
28.
28, yep. And here's why, okay? Because C has got to be ready to go for F, right? And so if it's not ready to go, then I can't start F, which then means I'm going to miss this start time, which is going to put me, it's going to delay the project, okay? All right? So then if that latest finish time is 28 for C, what's the earliest start time? 21. So again, it's on the critical path because there's no slack time there. Okay? Scotty, let's look at D. D has 2 arrows coming back into it. One of them is 28 for the latest start time, and one of them is 31. Based on what we just said, what should this be?
28.
28, right? Because that task has to be done in order for this to meet that latest start time. Okay? And so then what's my latest start time for D?
26.
26, right? And then Hunter for B?
26
Mm-hmm.
and 21.
There we go. And then
21.
Kaylin?
21.
And 0, right? So when I look at this, the only thing that's not on a critical path that has any slack to it is right here. Okay? So I've shown you that how we kind of worked our way through that. Let's go ahead and look at maybe a prettier version of that then. Okay? So you can see they're doing the same thing that we just did, only I just walked you through it and wrote it up there. Okay? All right. Then it says we've determined the earliest start and finish time and the latest start and finish time. And right now you still don't understand why that's important. We're going to show that here in just a little bit. Okay? But we can identify a critical path at this times across any of the paths that exist. Okay? So you can look at this diagram and you can see that we have a path of A, C, F, and G. Okay? And that's going to be 21 plus 28 plus, I'm sorry, 21 plus 7 plus 8 plus 2. So if I look at those task times, right, and add those up, that tells me that's 38 weeks. Okay? Another path is A, B, D, E, and G. Okay? A, B, D, E, and G is then 21 plus 5 plus 2 plus 5 plus 2. That's 35. Okay? So right now I know that path is not the critical path, right? Because the other path was 38 weeks, so it was longer. So whichever one is your longest is going to be your critical path. Okay? But I also want to look at A, B, D, F, and G, right? There's another path that we've got, and that's going to add up to 38. So we have 2 critical paths here. Okay? And I can look at A, C, E, and G. That's the 4th path that we've got, and it's going to be 35. So again, I've got 2 critical paths in this project. And so again, it's important to note that you can have more than one critical path. All right? And so a lot of times, let's just do a quick draw here. So if I go AC, F, and G, right? We'll do that as path 1. And that's 38 weeks. Kind of messy, but you get the idea. And then we can do A, B, D, E, and G. And what's interesting is, of course, there's more steps in that. but it's actually 35 weeks. Okay, and then we also have A, B, D, F, and G. And we also have A, C, E, and G. So you can see those 4 different paths that we looked at. Looks like a mess, but you get the general idea. Okay. Of course, they do it much prettier there. All right, so then what we're going to do is we're going to take those earliest start times and earliest finish times and latest start times and latest finish times and transform them into a table. Okay? Because in that, then when we have that table, we can determine our slack time. Okay? And so your slack time, you can look at either your start times or your finish times. So if I take 21 minus 21, that's 0, right? 0 minus 0 is 0. If I use, let's just use latest finish times, right? So if I do 26 minus the earliest finish time of 26, that tells me I have 0 slack time. 28 minus 28 is 0. 28 minus 28 is 0. 36 minus 33 is 3. 36 minus 36 is 0. 38 minus 38 is 0. It's saying that the only task that I have any flexibility on is E. So what that means is if you're managing the project and you're having trouble with task D, right, you might consider taking resources from E, whoever's working on E, and saying, look, why don't you hold off on that for a week or 2 and let's help out on D so we can keep that on target, right? So again, that's what that slack time can tell you, all right? And the thing about it is we did it using the finish time, but you can also do it using the start time. 0 minus 0 is 0, 21 minus 21 is 0. You can see all of those are the same. Then we get down here, it's 31 minus 28, that's 3, right? So you can do it, you can calculate slack time by using finishing times or starting times. It doesn't matter. And the other thing is, it's a good double check, because if they match, that means you're probably right. But if you get to one where the finish time, latest finish time minus earliest finish time is different than latest start time minus earliest start time, it's a clue that you've got a problem, right? You've not done something right, so you need to go back and look, okay? All right. And if you'll note, all of those slacks of 0, that means that they're on the critical path. All right. Let me just do a quick, what time have we got?
10:36.
10:36, okay, so I have about 9 more minutes then. All right, so again, then if we come back to Appendix 4.2, so we were kind of working out of that alternate text. This is just some information from Appendix 4.2. All activities that lie along the critical path are labeled critical activities. A delay in executing any of those critical activities delays the completion of the whole project. Slack time of an activity is equal to the extent to which an activity can be delayed without affecting the flow time. So if you go over 3 weeks on that slack time, you've now impacted the project. That's what that information is telling you. Okay? Computation of slack time involves identifying earliest start time, earliest finish time, latest finish time, and latest start time. All right? And again, remember that earliest start time, earliest finish time moves from left to right across the diagram. Latest finish time, latest start time moves from right to left backwards. So you're doing the top of the diagram, those T charts as you go across, and you're doing the bottom as you go back. Okay? Slack time can either be latest start time minus earliest start time or latest finish time minus earliest finish time. You systematically calculate slack time by utilizing the forward scheduling, that's going left to right, or backward scheduling, going right to left. Okay? All right, so here's another example, right? And so basically, we can say, let's do our T diagram. And it's task 1, and we're going to say these are in days. And so task 1 takes 20 days, all right? So I'm going to start and go across. Courtney, what am I going to start with? What's
You want to start with 0, and you'll have 21?
20, actually.
20, sorry.
That's okay, all right? Then let's go Zach. Let's go to task 2. When does task 2 start?
Day 20.
Day 20. And how long is it going to take?
I guess, what is 55 days?
Yeah, it's correct. Okay. Andrew, let's keep going on this path. So task 4 starts when?
On day 55 or 70.
55?
Yeah,
Yep.
55. And then it takes 65 days.
Yep, so it's going to finish on day 65. Okay. Emily, task 6 starts when?
65.
65. And ends when?
95.
95, right? Okay. Scotty, task 3 starts when?
20,
And ends?
45.
Hunter, task 5.
It would start on 45 and end on 65.
Okay, so Kaylin, you get the one where it comes together. Okay. So task 5 finishes on day 65. Task 6 finishes on day 95. And what we're saying, so this is the logic that we have to remember. Do you remember what we're saying? Both of these tasks have to be done before I can start task 7.
So we want it to be 65, don't we?
It has to be 95 because so on the way across you're taking, so I want you to get the logic, but the rule of thumb is on the way across you take the higher number, okay? When you're going left to right, you take the higher number, okay? Because both of those tasks have to be done before I can start task 7, okay? So it's like trying to put the toppings on the pizza before you have the crust and the sauce down, okay? So I need both the crust and the sauce, so it's going to be 95, and it's going to finish when?
110.
Yep. Okay. All right. Courtney, back to you. Task 8 starts when?
110,
And finishes when?
150.
Right. Okay. So now we're going to move our way. We're going to do our backward scheduling, and we're going to go back across it. Zach, what's the latest finish time?
Is it 110?
It's actually, you just drop this one right back down.
Okay.
Latest finish time is 150, and I subtract my 40, so my latest start time is 110. Okay? So almost always on this last task, these things are going to be identical. Almost always. Okay? Andrew, if my latest start time is 110, what can my latest finish time on task 7 be?
110.
110, right? And so again, because that matches, this is going to match, right? Okay? All right. So then, Emily, if I go from task 7 to task 5, task 7's latest start time is 95, so task 5's latest finish time is going to be 95. Okay? 95 minus 20 is
75.
75, correct. Okay, Scotty, task 3.
75
Mm-hmm.
and then 50.
Mm-hmm. Hunter, what have I got down here on task 6?
Be 50. Oh, on task 6, I was going on to 1. That would be 95.
95?
Yeah, that's what you're
And
right.
so then, because
And
that's the same, this
minus
is
30. Yeah,
yep,
so.
minus 30 is 65. Okay. Kaylin?
65
Mm-hmm.
and 55.
Right. So you guys are, you're kind of getting the hang of this. There's only a couple of spots where it gets tricky. Okay, so here we are. We're at 55. And so, Courtney, what's the latest finish time here?
55.
55, making the latest start time?
20.
20. Okay. So, now's where we get tricky. Zach, we're coming back we've got 2 arrows coming back into this on the way back. And one of them says that the latest start time can be 50. And one of them says the latest start time can be 20. Okay? And so this has got to be done, right, before I can start this. And its latest start time is 20. So what's going to be the latest finish time on this?
20.
Yep. So I really want you to get the logic behind it, but the rule of thumb is on the way across, you're taking the higher number, and on the way back, you're taking the lower number. Okay? But the logic behind it is saying on the way across, every item has to be done before you can start it. And on the way back, you're saying, this is the latest day I can start this. So whatever's right before that has to be finished by that time. Does that make sense? Okay? So again, these aren't that hard to do. So now, again, we've drawn our precedence diagram, right? This is the data, all right? And if we wanted to say critical path, right, we add up, there's 2 different paths. We have, path 1 is 1, 3, 5, 7, and 8. Path 2 is 1, 2, 4, 6, 7, and 8. okay? The times for those, path 1, 1, 3, 5, 7, and 8 is 120 days, and path 2, 1, 2, 4, 6, 7, and 8 is 150 days. So which one is our critical path? Path 1 is 120 days, path 2 is 150 days. Which one is our critical path?
Bigger one.
Say that again.
Bigger one.
150 days.
150 days, right? And if you note, right, there is no slack time on any of these activities, right? And if I look up here, I have slack time on these activities. What's my slack time on task 3?
30
30
days.
days.
30 days, right? What's my slack time on task 5?
30 days.
30 days, right? So I have some slack time on those, all right? And so, again, the prettier way to do it is then to transfer it into the table and then calculate your slack time by subtracting latest finish, latest start, or earliest start, latest start, right? Okay? All right. That's what your homework is going to be, okay? The biggest challenge you're going to have with your homework is figuring out how to draw the diagram and get it to post in the discussion board. The guy that did it last semester that had, I think, the easiest success with it used like one of those picture drawing. Usually a lot of you have on your software, you've got kind of a picture drawing thing, and you can draw in there and then take it and copy and paste it in. Hunter?
Can't you do it in Excel and then make it a Word, like a picture in Word, and then copy the picture into there, or will that work? Not work?
You can sure try that. There's sometimes that works for people and sometimes it doesn't when you go to post it to the discussion board.
Okay.
Okay? So typically what I do is I post them in a PowerPoint because I have better luck with the PowerPoint diagrams posting and showing than I do coming out of Excel. But you're going to have to spend just a little bit of time maybe manipulating that. And you want to spend that time to get it figured out early in the semester because we'll have several assignments where you'll need to post diagrams. Okay? And I would tell you exactly how to do it, but everybody's computers and softwares are just slightly different. So spend a little time getting that figured out. Appreciate your time and attention today. You need to hand in the sheet that says 3 things that weren't just directly off the PowerPoints. And again, we'll see you back here on Thursday, and we'll be going over some different information on projects and how to work through some things.